Hello, Namaste. Today I am going to show you the video of solution of certain selected problem from the binomial expansions of the basic math of grade 12. I hope you will divide these lessons during this lockdown period. Okay, let us start the solutions. Question number 1, solution. So what we have in the question number 1? The middle term in the expansion of k by 2 plus 2 whole power 8 is 1120. Find value of k. So here the given binomial is k by 2 plus 2 whole power 8, and so a is k by 2 and x is 2 and n is 8. It is even, and so the middle term is, there is only one middle term, so middle term, t n by 2 plus 1 is 1120, because only one middle term, so t n by 2 plus 1, it is given by this one. So now we have a formula that t n by 2 plus 1 equal to c n times n comma n by 2 times e to the power n by 2 times x to the power n by 2. This is the formula of single middle terms within the expansion of the binomials. So the value of t n by plus 1 by 2 is 1120, and c n is 8 and n by 2, that is 8 by 2, that is 4 times a is k by 2 whole power 4, x is 2 whole power 4. So on simplifications, 1120 equals 8 factorial by 8 minus 4 factorials, 4 factorials times k to the power 4 to the power 4 times 2 to the power 4. What we have done here, this is the formula of combinations, this one, okay? So it is 4, and 4 and 4 cancel out. We get 1120 equal to 8 into 7 into 6 into 5 into 4. Why up to 4? Because we have 4 factorial here. 8 minus 4 is 4 factorial, and 4 factorial can be expanded as 4 into 3 into 2 into 1 times k to the power 4. So we have now cancel this 2. On simplifications, you do yourself. Further simplifications, we get 70 k to the power 4, and this also gives k to the power 4 equal to, this gives 16, okay, or k to the power 4 equal to 2 to the power 4, and this implies k equal to 2. By law of indices, this is the required value of 2, k. Okay, this is the solution of question number 1. Where's the duster? Yeah, it is here. Okay, now we solve next questions. Question number 2. If the coefficient of x7 and x8 in the expansion of 3 plus x by 2 power n are equal, find n. So here the given binomial is 3 plus x by 2 whole power n. So comparing with a plus x whole power n, we get a is 3, x is x by 2, and n is to be determined. Okay, one more condition that we have given, the coefficient of x8 and x to the power 8 and x to the power 7 are equal. So we find first the coefficient of x7 and x8, and to find that we have to go through the general term. We have the general term, t r plus 1 is equal to c n r times a n minus r times x r. Okay, so here we have to find the value of n. So C n r, a is 3, n minus r, and x is x by 2 whole power r. So this equal to C n r times 3 n by, using law of indices, okay, xr times 2 to the power r. So the coefficient of xr equal to cnr times 3n into xr, sorry, not xr, n divided by 2r. All these terms, these are the coefficient of xr. So to find the coefficient of x7, now therefore, coefficient of x7, we put r equal to 7 in this I. Okay. So Cn7 times 3 to the power n divided by, something is left here, 3 to the power r and 2 to the power r. Okay, one term is left missing. Okay, so 3 to the power 7 and 2 to the power 7. Okay, putting r equal to 7 in equation I, or relation I. Again, coefficient of x8 equal to C n8 into 3 to the power n divided by 3 to the power 8, 2 to the power 8. Putting r equal to 8 in equation first. Okay, so this is the coefficient of x8 and coefficient of x8. We have given that the coefficient of x7 and coefficient of x8 are equal. So from question, right here, questions, coefficient of x7 is equal to coefficient of x8. So we can write that C n7 times 3 to the power n divided by 2 to the power 7 equal to C n8 times 3 to the power n divided by 2 to the power 8 times 2 to the power 8. So what we have here, this 3n and 3n cancels. We expand the remaining term, and 3 to the power 8, 3 to the power 7. Okay. Also can be cancelled by 3 times and 2 times. Okay, now let us do it here. We have the remaining terms are C n, that is n factorial by n minus 7 first. 7 factorial, 7 minus 7 factorial and 7 factorial. Then another is into 3 to the power 7 and 2 to the power 7. And on the right, we get n factorial by 8, write down first, n minus 8 factorial times 3 to the power 8 into 2 to the power 8. Okay, so this and this cancel out 1 times. And look at here one thing, n minus 8 factorial can be written as n minus 8, n minus 9 factorial. But n minus 7 factorial can be written as n minus 7 times n minus 8 factorial. Okay, since we know that n factorial is n times n minus 1 factorial. So using this relation, we change this n minus 7. And similarly, 8 factorial is equal to 8 times 7 factorial. So 7 factorial and 7, they are common. So we change 8 factorial and n minus 7 factorial like this. What we get then? 1 by n minus 7 times n minus 8 factorial. And 7 factorial into 3 to the power 7 into 2 to the power 7 equal to 1 by n minus 8 factorial, 8 into 7 factorial, and this 3 to the power 8 is 3 to the power 7 times 3, okay, and 2 to the power 7 times 2, 2 to the power 8 is. So now we cancel the common factor from left hand side and right hand side, 3 7, 2 7. So what we have left? In the left hand side we have got only n minus 7. On the right hand side we have got 1 by 3 into 2. 3 into 2, that is 6. So 3 to the 6. 3 to the 6, okay. 8 also. It is 48. We have got 48. 8, 3, 2. 48. So by cross multiplication, n minus 7 equal to 48, or n equal to 48 plus 7, that is 55. This is the required value of n. This completes the solutions of 2. Okay. Now we solve the question number 3. Okay, let us clear it and clear the remaining part also. This also. Okay. In question number 3, the expansion given binomial is 1 plus x whole power m plus n. Yes. And what we have to prove? The coefficient of xm and xn are equal. We have to prove that. To prove coefficient of xm equal to coefficient of xn. Again here we start from the general terms. Okay. So here you know that n is the number of terms is m plus n. Okay, remember this. Now general term Cr plus 1 equal to Cnr times Xr. Okay, and since n is m plus n, so therefore general term of 1 plus x whole power m plus n equal to C m plus n, okay, r times x to the power r. This is the formula. In the expansion this, we write this. Okay, now put r equal to m. Then coefficient of xm equals, when we put r equal to m, then coefficient of xm, this becomes xm, then that we get c m plus n comma m, and this equal to m plus n factorial by m plus n minus m factorial times m factorial. Okay, and this is equal to m plus n factorial by m cancel out, n factorial times m factorial. This is the coefficient of xm. So let it be 1. Not necessary to this. Again, put r equal to n. Then coefficient of x n equal to c m plus n times comma n times x to the power n, not xn, and the coefficient of xn is cm plus n. Okay, we can write this. This becomes xn, and coefficient of xn is this one. So on simplifications, m plus n factorial by m plus n minus n factorial times n factorial. So this equals m plus n factorial by n and n got m factorial times n factorial. So look at here, the coefficient of xn m plus n factorial by n factorial and coefficient of xn m plus n m factorial m plus n factorial, the same quantity we have got. So hence coefficient of x n equal to coefficient of x n. This complete the proof of the questions. Okay, so we are using rule of combination here. No, we have used n factorial, n minus 1 factor, n minus r factorial by n factorial. Okay, now prove the question number 4. This one. Okay, let us see the question number 4. If the coefficient of 3 consecutive terms of expansions of 1 plus x whole power n are 220, 495 and 792, find n. Okay, so question number 4, solution. The given binomial is 1 plus x whole power n, and let the 3 consecutive terms are given. Let the 3 consecutive terms, coefficient of consecutive terms, let c r minus 1 equal to 220 and cr is equal to 495 and cr plus 1 is equal to 792. B 3 coefficient of the coefficient of 3 consecutive terms in expansion of 1 plus x whole power n. Okay, then by taking the ratio of first two and last two, we get 2 equations, and solving the 2 equations we can find the value of n. So taking the ratio of first two, that is cr minus 1 by cr equal to 220 by 495. So using the formula combinations, n factorial by n minus r minus 1, that is minus minus plus 1 factorial times r minus 1 factorial. This is in numerator. And in the case of denominator, n factorial by n minus r factorial times r factorial. On the right hand side, on simplifications, we get that 55 times the force is 220, so we get 4, and 55 times 9, that becomes 495. So yes, 4 by 9. Okay, this is the denominator, and 4 by 9. Okay, this cancels 4 by 9. Okay, and again we can cancel these 2 quantities, and we have got this n minus r factorial times r factorial by n minus r plus 1 factorial r minus 1 factorial. This is 4 by 9. So look at here. Now this n minus r and n minus r plus 1. This n minus r plus 1 can be changed by using this n minus r, n minus 1 factorial. So n minus r plus 1 factorial can be written as n minus r plus 1 times n minus r factorial. Okay, one of the factor can be obtained from this n minus r, and this is common to this same factor. So we change this one. Similarly, within these two, r factorial is r times r minus 1 factorial. So we change r factorial to this form so that we can cancel r minus 1 and r minus 1. So using this, we get that n minus r, we do not change it, but we change this r times r minus 1 factorial, and this n minus r plus 1 factorial can be changed to n minus r plus 1, n minus r factorial, and r minus 1 factorial as it is, 4 by 9. So the common factor from the numerator and denominator can be cancelled out by 1 times. We get the result r by n minus r plus 1 equal to 4 by 9, or 9r equal to 4n minus 4r plus 4 by cross multiplications. Okay, and this means 9, it becomes plus, and 9 plus 4 is 13r equal to 4n plus 4, or r equal to 4n plus 4 by 13. That is V1. Always find the value of r in such type of problems, okay, and replace in another relations. So again, now we take another ratio, that is from the CR and CR plus 1. Look at it here, we have divided this first term with second. Here also we divide the first term, that is CR, by CR plus 1. Okay, always it must be continuous. 495 divided by 792, and similarly CR is r factorial by n minus r factorial times r factorial, and this r plus 1 is n minus r plus 1, that is become minus 1 plus minus minus, okay, and r plus 1 factorial. Okay, no, this we have left here one thing. This is numerator, and in denominator, not this n factorial by n minus r minus 1 factorial times r plus 1 factorial. Okay, one thing you remember that in the expansion of 1 plus x whole power n, c1 means nc1, cr means ncr, okay, and cr, okay. Similarly, cr plus 1 means ncr plus 1. This is the well-known notations. So we have got this equal to. On simplifications, look here, 495 is, you can use calculator 5 times, okay, and similarly 99 times 8 times, okay. 8 9 is 72, 8 9 is 72 plus 7 equals 79. So we can write here 5 by 8. So the same factor from the numerator and denominators, okay, we can cancel them and we get this one. Okay, now the simplify here. So we get, so n minus r minus 1 factorial by r plus 1 factorial. Okay, since this denominator of denominator multiply the numerator of the numerator when we divide by the fractions. Okay, so we get this, and n minus r factorial times r factorial equal to 5 by 8. Okay, look at it now. So as here we have changed this r minus r plus 1 to get this factor. Similarly here we change this to get this one, because n minus r factorial is n minus r times n minus r minus 1 factorial, same factor. Similarly, the r plus 1 factorial is r plus 1 times r factorial. Okay, so using this result, so that we get the common factor, we use like this. So n minus r, we do not change it. R plus 1 can be changed to this form, and n minus r can be changed to n minus r minus 1 factorial and r factorial, and this is equal to 5 by 8. Okay, let's clear it. We have to find the value of n, so let us clear this questions also. I will do this in the another video because the time is being long. Or, and common factor from numerator and denominator cancel by 1 times, we get r plus 1 by n minus r equal to 5 by 8. Now by cross multiplications, 8r plus 8 equal to 5n minus 5r. Taking this 5r to the left, we get 13r, and taking this 8 to the right, we get 5 minus 8. Okay, and then now we put the value of r from 1. Putting value of r from I, we get 13 into 4n plus 4 by 13 equal to 5n minus 8. And this 13 and 13, the common factor can cancel out. So this, taking this 8 to the left, 8, 5n minus 4n, and taking 4n to the right, the sign is changed, plus changed to minus, minus changed to plus, 12 equal to n. So hence n equal to 12 is the required answer of this question number 4. Okay, thank you for watching this video. The duration is longer than 25 minutes or 30 minutes, so I'm not able to solve the question number 5 in this video. We solve that problem in another videos. You can see in another video. Thank you for watching this video.